Let's do another example. Take a look at one kind of like number 9. So number 9 reads, for visible light, it says the wavelengths of visible light ranges from 400 nano to 700 nano. And again, we'll want to be comfortable with that. We want to be able to look at this and go, oh, 400 nanometers, that's the violet end. And 700 nanometers, that's the red end. So that's somewhat important. It says, find the corresponding ranges of this light's frequency, angular frequency, and wave number. Okay. So the visible light goes from our 400 nanometers to 700 nanometers. And they want us to calculate various quantities. They want us to find the, the frequency, the angular frequency, and then the wave number. Okay. Let's just pick one of these. Do y'all want to work with the violet or the red? Which end would you prefer to look at? We're just going to do one of these. The red end? Okay, excellent. So this was violet, because I want to practice that we get used to identifying those. And then this is the red end. And so then let's run red. All right, so this is our wavelength for red, and they want the frequency. And so then what we can look at is we can look at the formula that V is equal to lambda F. And then if we divide both sides by the wavelength, and again, we remember that this is in a vacuum, and so this is C is V, then what we'll get is we can calculate our frequency for the red end of the visible spectrum, okay? And so then our frequency will be C over lambda. So this is our 3 times 10 to the 8th meters per second. And then the lambda is 700. And then the decimal is here. So be careful with that. Nano is times 10 to the minus 9. So this number is not in scientific notation. So you just got to be a little careful with it. Okay. What will we get for the frequency of the red end of the visible spectrum? Thank you. 4.29 10 to the 14. This will be in hertz. So that's the answer to the first part, part A. And then let's go in and let's find the angular frequency. Okay. And so for our angular frequency, we know that omega is that 2 pi times F. And again, I don't know if this was important to y'all, but I guess I had a hard time for some reason when I was picking this stuff up, and I couldn't remember how the 2 pi's went. And because they wrote them both ways, and so then they all just blurred together. And so really what we're doing is converting the revolutions in the F frequency into radians for the omega frequency, but then we don't write the radians and we don't write the revolutions and you don't write divide by 1. So then you just get 2 pi. So I don't know. 2 pi times this frequency, 4.29 times 10 to the 14 gives us what value for the angular frequency of the red end of the visible spectrum. And I can mark these as F red, I guess. I'll mark this one as omega red. Get 2.695 10 to the 15, and that'll be in the radians per second. Okay. And then we can go in and take a look at our wave number, which I probably would have called the angular wave number, but that's okay. It's all fine. So here's the first one, here's the second one. And so when we go in to find the K, one way to do this is we can go in and state that, K was 2 pi divided by lambda. And we already know the lambda. So then this is 2 pi divided by our 700, and the decimal is here, times 10 to the minus 9. And so then this will be the K for red. So 8.98, 10 to the 6. And this will be in radians per meter. Okay.